Suppose think of a batsman batting average in cricket. Batting average in cricket represents how many runs a batsman would score before getting out. For example, if a batsman had scored 50 runs out of 100 from boundaries in the previous match, then there is a chance that he would score 50% of his runs in the next match from boundaries. Now, let us consider another example. Winning or losing a lottery is one of the most interesting examples of probability. In a typical lottery draw, suppose each player chooses 6 distinct numbers from a particular range. If all the 6 numbers on a ticket match with that of the winning lottery ticket, the ticket holder is a jackpot winner. The probability of this event happening is 1 out of 10 lakhs. So before we discuss what probability is, let us know what an experiment and event is according to probability. An experiment or trial can be any procedure that can be infinitely repeated and has well-known set of possible outcomes, known as sample space. Sometimes this experiment is said to be random experiment if it has more than one possible outcome. Now, let us define what is an event. An event is an outcome or well-defined collection of outcomes of a random experiment. Having defined these terms, let us see what probability is. Probability is the extent to which an event is likely to occur, measured by the ratio of the favorable cases to the whole number of cases available. There exist two types of probabilities, that is, empirical probability and theoretical probability. Let us consider an example to understand this concept. If you are rolling a die 10 times and number 3 appears 2 times, experimentally you can say that probability of getting 3 is 2 divided by 10. But if you want to define it in the theoretical way by reasoning, the probability of getting number 3 is 1 divided by 6. Therefore, the result of probability based on the actual experiment is called the experimental or empirical probability. Empirical probability is denoted by P of E, where E is the event. Therefore, P of E is given by number of trials in which the event has happened divided by the total number of trials. Probability that is determined on the basis of reasoning is called theoretical probability. Therefore, probability of an event E is given by number of outcomes favorable to E divided by the number of all possible outcomes of the experiment. Let us consider an example to understand it clearly. Find the probability of getting a head when a coin is tossed once. Also, find the probability of getting a tail. In the experiment, if you toss a coin once, the number of possible outcomes is 2. That is, you get a head H and tail T. Let E be the event getting a head. The number of outcomes favorable to E, that is, of getting a head, is 1. Therefore, P of E is equal to P of head is equal to number of outcomes favorable to E divided by the number of all possible outcomes, which is equal to half. Similarly, if F is the event getting a tail, then P of F is equal to P of tail, which is equal to half again, because the sum of the probabilities of all the possibilities is equal to 1, which is called as the sure event. Likewise, the probability of an impossible event is 0. Therefore, if we have the same possibility of getting each outcome, then it is called equally likely outcomes. An event having only one outcome of the experiment is called an elementary event. Here, both the events E and F are elementary events. Now, let us consider another example. Suppose we throw a die once. What is the probability of getting a number greater than 4, and what is the probability of getting a number less than or equal to 4? Here, let E be the event getting a number greater than 4. The number of possible outcomes when throwing a die is 6. That is 1, 2, 3, 4, 5 and 6. And the outcomes favorable to E are 5 and 6. Therefore, the number of outcomes favorable to E is 2. So, P of E is equal to number greater than 4, which is equal to 2 divided by 6, giving you 1 divided by 3. Now, let F be the event getting a number less than or equal to 4. Number of possible outcomes here is 6. Outcomes favorable to the event F are 1, 2, 3 and 4. So, the number of outcomes favorable to F is now 4. Therefore, P of F is equal to 4 divided by 6, giving you 2 divided by 3. Are the events E and F in the example above elementary events? No, they are not, because the event E has 2 outcomes and the event F has 4 outcomes. That is, P of E plus P of F is equal to 1 divided by 3 plus 2 divided by 3 is equal to 1, where E is the event getting a number greater than 4 and F is the event getting a number less than or equal to 4. Note that getting a number not greater than 4 is same as getting a number less than or equal to 4 and vice versa. Here, F can be denoted as not E, which is basically the complement of E. So, probability of the event E plus the probability of E naught or complement of E is equal to 1. This event E representing not E is called the complement of the event E. Therefore, E and not E are complementary events. So, let us now throw a die. The only possible outcomes of the die are 1, 2, 3, 4, 5 and 6. Would you get an outcome 0 or 8 if you throw the same die? There is no face of the die marked as 0 or 8. So, there is no outcome favorable to 0 or 8. That is, the number of such outcomes is 0. In other words, getting 8 or 0 in a single throw of a die is impossible. So, P getting 0 or 8 is 0 divided by 6, which is equal to 0. That is, the probability of an event which is impossible to occur is 0. This particular event is called an impossible event. Now, we know that all of the sides of the die have a number less than 7, right? So, what would be the number of the favorable outcomes? So, the number of favorable outcomes is the same as the number of all possible outcomes, which is 6. Therefore, probability of E is equal to P getting a number less than 7 is equal to 6 divided by 6, which is 1. So, the probability of an event which is sure or certain to be occur is 1. Such an event is called a sure event or a certain event. Also, you have to consider an important note that from the probability P of E, the numerator, that is number of outcomes favorable to the event E, is always less than or equal to the denominator, that is the number of all possible outcomes. Therefore, 0 less than or equal to probability of event E, which tends to be lesser than or equal to 1. Now, let's consider an example. Anne and Bindu are friends. What is the probability that both will have different birthdays and the same birthday? Let's ignore the leap year. Solution for the same is as follows. Out of the two friends, Anne says her birthday can be any day of the year. Now, Bindu's birthday can also be any day of 365 days in the year. We assume that these 365 outcomes are equally likely. Now, the first subpart, that is, if Bindu's birthday is different from Anne's, the number of favorable outcomes for her birthday is 365 minus 1, which is equal to 364. So, probability of Bindu's birthday is different from Anne's birthday is equal to 364 divided by 365. Now, the second subpart, probability of Anne and Bindu having the same birthday, which is equal to 1 minus probability of both having different birthdays, which is equal to 1 minus 364 divided by 365 using P of E is equal to 1 minus P of E, which is equal to 1 divided by 365. Let us summarize. Empirical probability P of E is given by number of trials in which the event has happened divided by the total number of trials. Theoretical probability P of E is given by number of outcomes favorable to E divided by the number of all possible outcomes of the experiment. The probability of a sure event or a certain event is 1, and the probability of an impossible event is 0. An event having only one outcome is called an elementary event. The sum of the probabilities of all the elementary events of an experiment is 1. For any event E, probability of E plus probability of complement of E is equal to 1, where E complement stands for not E. E and not E are called complementary events. The probability of an event E is a number P of E such that 0 less than or equal to probability of event E, which tends to be less than or equal to 1.